All right, today we are talking about something different. It's a material so dense, so incredibly strong, that it practically rewrites the rules of physics. So I want you to forget everything you think you know about matter, because we are diving into something truly bizarre: nuclear pasta. Now, to even begin to understand this stuff, you have to wrap your head around density on a cosmic scale. Inside a neutron star, matter is crushed to a point that is almost impossible to imagine. We're talking 100 trillion grams per cubic centimeter. Okay, so what does that number even mean in the real world? Well, if you could somehow fly out to a neutron star and scoop up just a single teaspoon of it, that little teaspoon would weigh as much as a mountain. Billions of tons. It is an environment so extreme, it's totally alien to anything we have here on Earth. So what is a neutron star really? Well, when a star way, way bigger than our sun reaches the end of its life, it goes out in a spectacular explosion called a supernova. And what's left behind is its collapsed core. Imagine the mass of our sun squeezed down into a ball that's only about 12 kilometers across. The gravity there is so powerful, it completely changes how matter itself behaves. You know, this idea has actually been around for a while. It was first predicted way back in the 1930s, but it took more than 30 years for our technology to actually find one. Then, in 1967, astronomers picked up this really weird pulsing radio signal from space, and it turned out to be the beam from a rapidly spinning neutron star, what we now call a pulsar. So finding them was a massive deal, right? But it also opened up this huge new question. Okay, we can see them spinning out there in the cosmos, but what are they actually made of? What in the world happens to matter when you subject it to that kind of insane, crushing pressure? To get to the bottom of that, we have to take a journey. We're going to peel back the layers of one of these impossible objects, one by one, to see what's really hiding deep down inside. You see, a neutron star isn't just one solid ball of stuff. It has layers. On the very outside, there's this paper-thin atmosphere. Right below that, you've got the outer crust, which is basically a super rigid crystal made of iron. But it's when you go deeper, into the inner crust, that's where things get really weird. The pressure becomes so immense that normal matter just can't exist, and it starts to break down and rebuild itself in some truly bizarre ways. And this brings us to the main course. It's in this strange transitional layer, the inner crust, that scientists believe matter arranges itself into something they've playfully nicknamed nuclear pasta. So what is it exactly? Well, think of it like a cosmic tug of war. You've got the strong nuclear force, which is like a superglue trying to hold protons and neutrons together, but at the same time, the protons are all positively charged, so they're trying to push each other apart. In the unbelievable pressure of the inner crust, these two forces basically fight to a draw, and it forces all the particles to line up in these incredibly complex shapes. At the top of this weird zone, where the density is just starting to get nuts, the nuclei get squeezed into these dense little spherical clumps, and yep, scientists call this phase gnocchi, like little nuclear dumplings. As you go deeper and the pressure ramps up, those little gnocchi clumps can't hold their shape anymore, so they fuse together and they form these long, stringy structures. You can probably guess what they call this phase: spaghetti. And if you go deeper still, right near the edge of the star's core, all those spaghetti strings merge together into these huge flat sheets of nuclear matter. And this phase, of course, is called lasagna. After this point, the pasta just dissolves into a kind of uniform soup of particles that makes up the star's core. Okay, I know what you're thinking. This is a pretty wild theory, but it brings up the obvious question. How could we ever prove this stuff actually exists from light years away? Well, it turns out the answer was hiding in plain sight, in the way these stars spin. For a long time, nuclear pasta was just a cool idea that came out of computer simulations. I mean, it made sense on paper, but finding actual observational proof from across the galaxy, that seemed next to impossible. And this is where the mystery really kicks in. See, pulsars are like cosmic spinning tops. They slowly lose energy and spin down over time. Now, our models, which assumed the crust was just a simple, perfect crystal, predicted a certain rate of slowdown. But when we actually looked at the real pulsars out there, the data didn't line up. They just weren't slowing down as fast as they should be. It was a real puzzle. Our theory and reality were not on the same page. So here's the breakthrough. Someone asked, what if the crust isn't a perfect, orderly crystal? What if it's a messy, disordered jumble of nuclear pasta? Think about it this way. Electricity flows really easily through an orderly structure, like water through a clean pipe. but a messy, jumbled-up structure creates a lot more resistance. Well, this higher electrical resistance from the pasta crust would cause the star's magnetic field to decay much, much faster. And since the magnetic field is what's acting like a brake on the pulsar's spin, a faster decaying brake perfectly explains why they don't slow down as much as the old models said they should. And just like that, the case was cracked. This mystery that had stumped astrophysicists for years suddenly made perfect sense. The spin rates of these distant stars, these little dots of light we see in our telescopes, provided the first real-world evidence that this incredibly bizarre cosmic pasta is likely the real deal. No, look, this whole discovery is about way more than just finding weird pasta in space. It's actually part of a much bigger scientific quest to figure out the fundamental rules that govern matter under the most extreme conditions you can possibly imagine. Physicists are on the hunt for something they call the equation of state. You can basically think of it as the ultimate recipe book for a neutron star. It's the set of rules that tells you exactly how pressure, density, and temperature all relate to each other in these extreme environments. And figuring this out is kind of a holy grail for physics. And there are a ton of competing ideas for what this ultimate recipe might look like. Some models suggest it's all just made of familiar particles like protons and neutrons, just packed together impossibly tight. Other theories propose that deep inside the core, the protons and neutrons themselves dissolve into their most basic building blocks, an exotic soup of quarks. The nuclear pasta theory is just one piece of this giant puzzle. But here's the really exciting part. With amazing new tools like gravitational wave observatories and next-generation X-ray telescopes, we are finally starting to gather the super precise data we need to test all of these wild theories and figure out which one is actually right. So it kind of leaves you with this incredible thought, right? We started with the remnant of a dead star and ended up with a theory about cosmic pasta that actually solves a real astronomical mystery. And it just makes you wonder, if matter can arrange itself into something this weird and wonderful, what other impossible materials are still hiding out there in the universe's most extreme corners, just waiting for us to find them?